Alright, I want us to look at differentiating natural log and differentiating log. Let's look at the similarities. You can stand them as the same, but there's just a fractional difference. Very minute, very subtle. Now, we all know that d dx for ln x is 1 over x. If you differentiate ln x, you're going to get 1 over x. Why is that? Because of this formula, this rule. Now let's look at it. This is, if you are differentiating ln u, you're going to get u prime all over u. Now let's allow that happen with ln x. d dx for ln x. Now remember, u prime, what is our u? Our u is what? X. So if u equals x, therefore u prime is what? If you differentiate x, what will you get? 1. Remember, it is u prime over u. Hence, we're going to get u prime is what? 1. Our u is what? X. So we have d dx for ln x is what? 1 over x. Now, if you come to this is log, this is natural log, this is log. Let me just state the slight difference before we take other questions. Now, this is the same thing. U prime over u times ln a. This is u prime over u. Why? Do we have ln a and we don't have any ln a? Because the natural base, the base for the natural log is e. And if we impute an ln e here, ln e is what? 1. ln e is 1. 1 times u is still u. Natural log, the base of natural log is e. So if we write ln e, it's going to give us 1. 1 times u is still u. That's why in the natural log, we just don't put anything here. Because the ln e is still 1, and our u will still be our u. But in this case, for log, your log, the base differs for your log. You could be base 2, it could be base, like your basic calculator, the base is 10. But we could have bases in other, we could have this log in other bases like base 2, base 5, base 7, base 8, base 9. It could be in any other base. That's why we have an a here. So we're going to take into consideration the value of that base. That's why we have ln a. But here is e. For natural log, it is just e. There is no other base other than e, and ln e is 1. That is why. So let's take other examples for natural log. Let's take ln x cubed. First, are you with me? Let's check ln x d dx. So d dx ln what? X cubed. Let's see. Now, you could take this power out here. Natural log allows you to take your power to this place. Become 3 ln x. Now, ln x is what? 1 over x. If you differentiate ln x, you get 1 over x times 3. You will get what? 3. So your final answer was 3 over x. But let's solve it the other way and see. Let's use this formula and see what we get. Now, our u will be what? X cubed. If our u is x cubed, therefore u prime will give us what? 3x squared. Now let's use the formula. U prime over u. U prime over u, that is 3x squared. 3x squared over what? X cubed. Now what does this mean? This means what? 3x all over x. So 1, 2 cancels 1, 2. We are left with what? 3 over x. The same thing we got initially. So that is correct for this case. So we take another question there. Sorry, we take another question. We have another question there. We have ln x raised to the power 4 minus x raised to the power 5. X raised to the power 4 negative x raised to the power 5. Now, the same thing we do. Our u is going to be everything inside here. So, u equals x raised to the power 4 negative x raised to the power 5. Hence, u prime is going to be what? 4x cubed negative 5x raised to the power 4. So, we use the formula u prime over u, and we're good. 4x cubed negative 5x raised to the power 4. All over what? U is x raised to the power 4 negative x raised to the power 5. Now, we can factor. If we factor out what can we factor out here? We can factor out an x cube. An x cube here will leave us with what? 4 negative 5x all over. What can we factor out here? We can factor out an x raised to the power 4. We're going to get what? 1 minus x. 1 minus x. So if these two cancels out, our final answer should be what? 4 negative 5x all over x into bracket 1 minus x. And this is our answer for this expression. This is our answer for this. Okay, we have a question here. Dx of ln and x. This time around we're differentiating a trig function. Now, the first thing we're still going to state this strict formula. But first we need to state our u. Our u is whatever we have inside our ln. So our u is going to be our u equals to what? X. Then our u prime. Differentiate now, what do you get? You get what? Sec square. Now remember, the formula is what? U prime all over u. So you can write that. Our u prime is what? Sec square. X all over what? Tan x. This is our answer. But we can further break this down. We can further break this down by sec square x. You can write that 1 square over cos square. Write this as what? 1 square all over what? Cos x squared. But I don't want to write 1 square. 1 square is still what? 1. I'll leave that. All over tan is what? Sine over cos. Sine x over cos x. Now we have that. So this one gives us this. Now we can multiply the numerator and the denominator by what? Cos square. And this is what's going to give us. Cos square x, cos square x. If I do that, this will cut out with this. Numerator we have 1. Now all over, if we have cos square cutting out with cos, we still have what? 1 more cos x here. We have 1 more cos x here. So we have what? Sin x times cos x as our denominator. We have what? Sin x times what? Cos x. And this can be further broken as 1 over sin x times 1 over cos x. 1 over sin x is what? Cosecant. 1 over sin x is what? Cosecant. So we write what? Cosec x. Then 1 over cos is what? Sec x. Now this is our answer. So this, if you break this down, gives you what? Sec x and cosec x times sec x. So this is our answer. This is also our answer. But if you like to take it down to this one, it's still good. Depends on what your lecturer prefers.